Maple TA Lesson 11B, homework question number 5. Graph the following nonlinear system of equations and identify the two solutions. The first one, y equals negative 2x squared plus 4x plus 1, and the second, y equals negative 2x plus 1. Oh, they were so nice to already write that in slope intercept form for us. The first one shows x squared being the highest degree. We do have an x to the first power, but we want to find the highest power here, which tells us that this is a quadratic equation and we'll graph a parabola. So we're going to select that this is quadratic. The second one has x to the first power, y to the first power, everything just pretty normal, so this is linear. The next is use the graph below to identify the two solutions to this nonlinear system of equations. Note, all solutions in this problem are whole numbers. None of the answers are decimals or fractions, which is nice because even as close as we can possibly get it, it might look a little bit off on our graph. So it's nice to know that we're looking for it to go through an actual corner in all of our graphs down here. The first thing I'm going to do is go ahead and graph the quadratic because it was listed first. And to graph this in Excel, you come over here, we need to find the vertex first and then the y-intercept, and it will graph it that way. So we're going to look for the vertex. To find the vertex, we need to memorize that the x value, or the x-coordinate of the vertex, is negative b divided by 2a. And in standard form, oh, and this, I can fix that once I copied and pasted it. In standard form, it goes a, b, and c for the coefficients. So our a is negative 2, our b is 4, and our c is 1. So I'll go down here and I want to find negative b. B is the second one, so 4, and it goes from x squared x to no x, and that's standard form. So that's how we know that it's A, B, and C. So we want negative 4 divided by 2 times A. 2 times, and A is negative 2. And you'll notice I put parentheses down there. That helps remind me that all of that is on the denominator of this calculation that I'm doing. So I need negative 4 divided by 2 times negative 2 is also negative 4. Negative 4 divided by negative 4 is positive 1. So my vertex, I know the first coordinate, or the x-coordinate, is going to be, I'm going to do this, positive 1, comma, and then we want to find the y value. Now, one way of notating this is that I'm going to plug all of the negative b over 2a back into the function. So I can say f of negative b over 2a. If that, it looks kind of scary, but it's not. It's just saying that we did some calculations, we found the x value, we put it back in the function, and it spit out the y value. So we're going to take our function here and put in positive 1 every single time we see x. So I'm going to go through and take out the x and put in parentheses to remind myself that I'm substituting, and I'm going to be putting in a 1. So in between those, I just type a 1. It's not too bad for this one. If it was a negative, it helps remind me that I'm not subtracting here, but that I'm being multiplied and stuff. So 1 squared, 1 times 1 is just 1. So this first one is 1 times negative 2. Come down here and paste for my next step. This is all 1. 1 times negative 2 is negative 2, so I'm going to leave that. And 4 times 1 is 4, so I can leave that too. So I end up with negative 2 plus 4 plus 1. Negative 2 plus 4 is positive 2. Positive 2 plus 1 is 3, and so my vertex is 1, 3. So we'll come down to our graph here, say I'm graphing my parabola, and my vertex is at x value first, meaning I move in the x direction, over 1, and then up 1, 2, 3, and then I'm going to try and get it in the corner as close as possible, and if I don't do very good, then I can move it around. I think that's pretty good. Now I need to find where it crosses another point, but it's easiest to do the y-intercept because to find the y-intercept, that's where it crosses the y-axis, and that means that x is 0. So I put 0 in and all the terms go to 0 except c. So I know that the y-intercept is positive 1. That's positive 1. Okay, so I'm going to come down here, the y-intercept, come positive 1 right here, try and go as close as possible. Okay, now you'll see that my parabola is going upside down. I'm going to double check that I've done that right by coming up and looking at A. A is -2, negative meaning I get a frowny face, and that's great, so it goes upside down. If it's positive, I get a happy face and it goes right side up. I know, it's kind of silly to think of it as a happy and frowny face, but it's a great mnemonic to remember that that's how the parabola is going to face. Okay, so the next thing, we want to graph our linear function right here, and it's wonderful. It's already in slope-intercept form, so we don't even have to do any calculations. The y-intercept is this last one, so it's positive 1, which, wonderful, is already here, so we already know that first, get it in there as close as possible. We already know that first point. The first solution is going to be right there at the y-intercept. The next point that we can find for a line is using our slope, -2. Now slope is rise over run, so I need to put this over a positive 1 because -2 divided by 1 keeps its value, and it then gives me a fraction of rise over run. So it means I need to rise -2, or in this case, because it's negative, go down 2, and run positive 1. So from this point, I'm going to go down 2 and run 1. And I could keep going. I could go down 2 from there and run 1. These will all be points on the line. And I can keep going down 2 over 1. It seems to be a little bit more accurate if I go down a couple, so that, in fact, if I go here, I notice that's exactly where this graph is going through, and that gives me my other solution. So these are our two solutions right here, and it's asking for the smallest, the one with the smallest x value. This is the x-axis, so I'm going to go to the left. These are the smallest, and this is my first solution right here. And it's the y-intercept for both of them, which is 0, positive 1. So the x is 0, the y is a positive 1, and then the other solution is over here, and I can see 1, 2, 3, and down 5. So my x is positive 3, and my y value is -5. There we go. And we can just verify that by how did I do, and it all looks good.